Imagine temperatures so extreme they just push everything to the limit, like plummeting down to -173 Celsius
Yeah.
for weeks on end.
Yeah, it's hard to even picture.
Or a world where these huge planet-wide dust storms, they just choke out the sunlight for so long that solar-powered machines just, well, they have to shut down.
Right. No power.
And then picture an environment, maybe near Jupiter, where the radiation is so intense it could, fry electronics in just hours.
These aren't just descriptions, are they? They're the actual realities our probes face.
Exactly.
Well,
So
sure.
the big question for our deep dive today is, how do our machines, our silent explorers, think NASA's rovers or China's AI moon crawlers, how do they actually survive this stuff, thrive even, where no human possibly could?
It's a fascinating challenge.
Yeah, so we're diving into how these space robots are, well, evolving, really, to handle the extreme conditions. The moon, Mars, places way beyond. And we're drawing insights from sources like AI, space robots conquering extreme planets.
It's a really insightful piece.
Our mission here is to sort of unpack how artificial intelligence, real-time decision-making, and these next-gen survival systems,
Mm.
how they're quietly becoming the absolute backbone of modern space missions.
The essential part.
Yeah, enabling these incredible machines to think, adapt, and just, well, endure where we can't. So to really get how they defy the odds, let's first paint a clearer picture of these environments. What are we actually up against?
Well, it's remarkable just how fundamentally hostile space is. You mentioned the moon's nights.
Right, the 14-day darkness.
Exactly. 14 Earth days of continuous dark. Think about that. 2 full weeks, no sunlight for solar panels. And temperatures plunging to that astonishing -173 Celsius.
Wow, that's incredibly cold.
And then you've got Mars. It whips up these massive planet-wide dust storms. They can block the sun, cutting off vital solar power, sometimes for weeks.
Weeks without power.
Yeah.
Okay, so you've covered Mars and the moon pretty starkly. Does the material point to other kinds of big environmental threats, things that really demand this advanced autonomy?
Oh, absolutely. The source material also highlights Jupiter's moon Europa. It's just bathed in intense radiation.
Right, the electronics frying kind.
Exactly, a severe threat.
Yeah.
It could destroy unprotected electronics in, well, maybe just hours.
Hours.
Yeah, and this really drives home why humans just can't be there. It's a basic limitation, It sets the stage for why robotic autonomy isn't just, helpful for exploring.
It's essential.
It's absolutely critical, non-negotiable, really.
Okay, that makes total sense.
Yeah.
Human control is out. But if they're not remote controlled, like, a drone in the park,
Hmm.
what is the core principle letting them operate out there?
Well, the fundamental answer is artificial intelligence, AI.
Okay.
And in this context, we're not really talking about, science fiction AI. It's more like the literal nervous system of these
A
missions.
nervous system, I like that.
It's what lets machines like NASA's Perseverance on Mars, or China's Chang'e 4 on the moon, it lets them not just move around, but actually actively think.
So when we say AI here,
Mm-hmm.
is this like the big language models we use on Earth? Or is it something really specialized for space? And I guess, why is it so crucial? Why not just better remote control?
That's a really good question. No, it's not like the generative AI we see a lot of now. This is highly specialized. It's mission-critical AI designed for specific tasks.
Okay.
And the why? Well, think about the signal delay. Sending a command to Mars takes minutes to arrive, minutes for the signal to get there, minutes for confirmation to come back.
Right, not like driving a remote control car.
Exactly, not instant feedback. That delay, that fundamental lag, it makes real-time human control completely impossible. The robot has to make its own decisions. Right there, right then.
To navigate, to survive.
Precisely, they have to operate as, well, truly independent agents.
That's really quite something. So how does this specialized AI actually, work on the ground? How does it handle navigating, avoiding danger when a human literally can't be steering?
Right, this is where it gets really practical. AI basically transforms the mission. It's not just following a pre-planned path anymore. It's dynamic, autonomous exploration.
Okay.
Because of those delays we talked about, the AI lets the robot make critical navigation choices all by itself. The source material gives great examples. The AI helps it decide, is this rock safe to drive over? Or is that patch of sand maybe a trap, a hidden soft spot it could get stuck in?
I see, so it can react instantly.
Exactly. It means a rover can see an unexpected crack in the ground and decide right then to go around it. It's thinking on its feet in a way remote control just can't allow. It's choosing safe paths, spotting dangers, surviving, all without direct, moment-by-moment human command.
And that real-time thinking must be even more critical for something like the lunar night, that brutal 14-day darkness with no solar power. How does AI manage that?
Yeah, that's a really unique, incredibly tough problem, and AI is crucial there. It has to manage the very limited battery power and deal with that extreme cold.
How does it decide what to do?
Well, it intelligently figures out exactly when to shut down systems that aren't essential.
To save power.
Right. And just as importantly, it decides what critical parts must be kept warm using precious energy to prevent them from freezing and breaking.
Okay, so it's making trade-offs.
Constantly. And it figures out the optimal time to wake back up, maybe when the sun is just about to rise. It's this really meticulous, intelligent power management that lets the rover survive those incredibly cold, long nights. Without that autonomous brain making those calls, it just wouldn't make it.
What's really striking, I think, is that this AI isn't just reacting. You said it's adaptive. How does that work? Can it learn?
Yes, exactly. And this is a key point from the sources we looked at. It underlines that the AI isn't just following a static set of rules, it's learning from experience.
Okay, how?
NASA's Perseverance rover is a perfect example. The AI allows it to essentially remember paths it took before, which ones worked well, and maybe more importantly, which ones almost led to trouble.
So it avoids making the same mistake twice.
Pretty much. It's almost like the rover is constantly updating its own internal map of the terrain on Mars. It learns from every little slip, every bump, kind of like a hiker gets better at navigating a tricky trail over time.
So it gets smarter with every step, as the source put it.
That's the idea. It learns and adapts based on its actual experiences on Mars.
So thinking bigger picture then, what does all this mean for where space exploration is headed? Are we really moving past missions where humans are in direct control?
Oh, absolutely. I mean, the future really belongs to autonomy. We're moving way beyond just needing a joystick on Earth.
You mean for complex missions?
Yes. Think about NASA's upcoming Dragonfly mission. It's heading to Saturn's moon Titan.
Right, the drone.
Exactly. It's a quadcopter, a drone. And it will fly by itself on Titan. Its AI will be making critical, potentially life or death decisions every single second, with no real-time help from Earth because of the immense distance.
Flying totally alone on an alien moon.
Completely self-guided. It's a huge leap.
Wow. And it's not just flying, is it? Are there other kinds of really bold, autonomous missions being talked about?
Yeah, the material also brings up concepts like, well, future submarines.
Submarines. Where?
Potentially navigating the oceans we think exist under Europa's icy crust, Jupiter's moon again.
Under the ice. Wow.
Yeah, imagine that. Operating completely autonomously. Relying only on AI for guidance, for making decisions, in an environment we literally can't see, under miles of ice, billions of miles away.
That's kind of mind-blowing. Relying entirely on AI.
It really stretches the imagination, doesn't it?
It does. So, okay, let's recap the core insight from this deep dive. From Mars, the moon, those icy moons like Europa, maybe even tougher places.
Yeah.
Our machines are surviving these incredibly brutal conditions. And it's not just because they're built tough.
Right, the hardware is amazing, but it's not the whole story.
It's really because of their intelligence, right?
Yeah.
Their AI. The source material really nailed it, I thought, saying AI isn't just part of the mission anymore.
It is the mission. Yeah, I thought that was powerful too.
It really is. It's the defining factor that lets us even be present robotically in these parts of the cosmos.
And, this is really just the beginning. It makes you think.
Yeah.
Well, I'd encourage you, the listener, to really consider what this means for humanity's future out there, when our explorers aren't just tools, not just extensions of our hands.
But intelligent agents?
Exactly. Increasingly intelligent, independent entities, making complex life or death calls all on their own, learning from their own experiences in these incredibly distant alien worlds.
How does that change things for us?
Right. How does that shift redefine our relationship with discovery itself, with the unknown, when our deepest explorations are led by machines that think for themselves? It's definitely something to ponder.